Hello, I'm Stefan, and this is a small movie I made about my bachelor thesis in biology. I'm originally from Estonia, but currently I'm studying in the Netherlands at Radboud University. For my final project, I wanted to do some hands-on field work in nature. Instead of staying in the Netherlands, I decided to return home to Estonia and work in a landscape I know very well. I got a chance to join a project that explores the use of an underwater drone, the Chasing M2, for studying fish populations. That was something I'd never done before, and it immediately felt like a good opportunity to combine technology, fieldwork, and ecology. Together with my supervisor, we planned a comparative study of two lakes with contrasting ecological characteristics. The goal was to see how lake type, specifically nutrient status, affects the structure of aquatic communities. We chose two natural lakes located in southeast Estonia. Lake Prosa is a small eutrophic lake. That means it is rich in nutrients like nitrogen and phosphorus, which often come from surrounding agricultural land. As a result, it supports dense vegetation, especially submerged aquatic plants or macrophytes, which cover up to 49% of the lake area. Lake Valgjärv is the opposite, an oligotrophic lake, low in nutrients with a clear water and low vegetation. I was curious, how would this difference in nutrient levels affect the food web? Would fish populations follow the same pattern as zooplankton or macroinvertebrates? Would we see more diversity in lake with more nutrients, or would the systems become unbalanced? To answer those questions, we designed a study that included not only underwater video surveys of fish but also sampling of zooplankton, phytoplankton, benthic macrofauna and water chemistry. This way, we could look at the whole structure, from the base of the food web to the top predators. Here are all the variables in the lakes that were taken into account, and in the end of this video, I will explain how these variables are connected and what kind of effect do they have on one another. But first, I will walk you through the methodology. In this clip, you can see me collecting the macrofauna samples using an Ekman grab sampler. And here are all the collected phytoplankton samples that were analyzed by Dr. Kai Piirsoo. In this clip, you can see Dr. Kathleen Blank looking at the zooplankton samples from Lake Prosa.
See on ka aereaalne, aga vaata tema on ka alanoidne, ehk et kuidas ma need ära tunnen, üks on hormikuline, kellel on lühikesed need.
Dr. Piirsoo and Blank helped me quantify and identify the samples of zoo and phytoplankton from both lakes and guided me through the whole process of how it's done. I also collected samples of water to see nutrient abundance in the lakes. The highlight of this research was, of course, the underwater drone. It is a completely new tool to study the fish diversity in a water body. Very few researchers have used this, and proper methods to use it for collecting data are still being developed. It is also a very cool way to do research. You don't often get the opportunity to navigate an underwater drone. The fish didn't seem to mind the drone too much. If they were in bigger schools, they tended to get quite close to the drone. Using the previously mentioned methods, I managed to get enough data to portray the dynamic interactions and show that lakes are more than just water. They are living systems with layers. At the bottom, producers, phytoplankton and aquatic plants turning sunlight and nutrients into life. Above them, primary consumers, zooplankton and macrofauna, feeding on those producers. And then secondary consumers, the fish. Some eat plants, some eat invertebrates, and some, like pike, eat other fish. It's a web. Each level affects the next one, and the entire structure changes depending on what the lake has or lacks. To quantify the differences of the trophic levels between the lakes, I conducted Bray-Curtis dissimilarity test and Shannon diversity index test. Bray-Curtis dissimilarity test shows how great are the differences between the species communities. This test takes into account the amount of species found and the population sizes. The test value ranges between 0 and 1, with 0 showing no differences and 1 showing complete differences between the populations. Shannon diversity index shows the diversity of the species in an area, a high value indicating high diversity and vice versa. With the collected data, I did not want to see how some variables, such as fish population and zooplankton populations, are correlated, but rather I wanted to see the differences of those populations between the lakes, and then discuss, based on theory and previous research, why did we see such differences. For results, I used R programming, which is a great tool for data analysis. First, I plotted the fish data and their populations in both lakes in the limnatic and littoral zones. Here you can see that the populations were very different in both zones of the two lakes. In the littoral zone, the common roach was the most dominating in both lakes. Perch was also quite abundant in the eutrophic lake, Lake Prussia, and undetected in the oligotrophic lake, Lake Nohipalu. The only other species found in Lake Nohipalu was pike, with a few individuals found in the littoral zone. Pike was also present in Lake Prussia, and even one individual of tench was found in the littoral zone of Lake Prussia. The Bray-Curtis dissimilarity test also showed that the communities between the lakes were very different, and Shannon Diversity Index shows how Lake Prussia had a higher diversity of fish species. The zooplankton, phytoplankton, and benthic macrofauna populations were all higher in Lake Prussia. Extremely low abundances of zooplankton were found in Lake Nohipalu Valgirb. We couldn't calculate the biomass for benthic macrofauna, so I decided to show it as Shannon Diversity Index instead. Here you can see clearly that the macrofauna diversity was higher in Lake Prussia. Now, when looking at the chemistry of the water bodies, you can also clearly see that the concentrations of nitrate, nitrogen dioxide, ammonia, and phosphate were all higher in Lake Prussia. There is some pattern here, as you can see. Now almost everything was higher in Lake Prussia. Fish species richness and abundance, zooplankton, phytoplankton, and benthic macrofauna were higher, and now also nutrient concentration. These values are all connected and greatly influence each other. I have constructed a feedback loop that shows how each variable influences another, or itself. The feedback loop starts with the most important factor that greatly determines the abundance of all other variables in the lake: nutrients. Phytoplankton and submerged macrophytes both pick up nutrients from the water body, so they are positively affected by nutrients, while they both decrease the amount of nutrients, so negatively affecting the nutrient abundance in the water body. Further, submerged macrophytes and phytoplankton both negatively influence each other because of competition. Zooplankton is positively affected by submerged macrophytes, while they eat submerged macrophytes and thus negatively affect them. Zooplankton is negatively affecting phytoplankton, while phytoplankton positively affects zooplankton because zooplankton eats phytoplankton. Further, some species of zooplankton eat themselves, thus negatively affecting their entire population. Benthic macrofauna eats submerged macrophytes, so they are positively affected and negatively affect submerged macrophytes, while benthos negatively affects phytoplankton by eating them and are thus positively affected. Zooplankton is negatively affected by benthic macrofauna, and this positively affects the benthic macrofauna. Benthic macrofauna also negatively affect themselves because some of the species eat other species. Fish negatively affects submerged macrophytes because they eat them, and then this again positively affects the fish. Further, fish also negatively affects phytoplankton by eating them, and this also positively affects the fish. Fish also eat zooplankton, so this negatively affects zooplankton, while fish also increases by eating them, and they also eat benthic macrofauna, and this also positively affects fish. And fish also consume on themselves, and this negatively affects their population. These results show that with more nutrients, you have more producers, more food, and more species. But it also shows how fragile that balance can be, and how change in one variable can greatly affect the whole ecosystem of a water body. Think about it next time when you're swimming in a lake, that almost everything you see in the water is part of a bigger system, serving its purpose with countless other variables. Thank you for watching.